Class, today's Geom Revise is to revise about standing waves. Okay class, now let's look at the first question we're going to analyze for year STPM 2019. The question is a string. Okay, what is it? A string. Okay, we have a string here, right? A string with one end attached to an oscillator. That means one end is attached to an oscillator of frequency 30 Hertz. Okay, the frequency of the oscillator is 30 Hertz. And the other end to a mass of 200 gram. Okay, so we have the other end fixed to a pulley, which is indirectly fixed to a mass of 200 gram. To produce what? Standing wave, as shown in the diagram below. Okay, so now they ask us to describe the formation of the standing wave, then they ask us to determine the wavelength, then they ask us to calculate the speed, and then they ask us to determine the mass unit length of the string. So let's go and learn a little bit more about standing wave. Okay, before we go further in solving the question, let's look at what is a standing wave. Okay, a standing wave is also known as a stationary wave. That means it is stationed in one place. Then we know also fact that in a standing wave, okay, based on my previous Geom Revive, wave profile does not move in the direction of wave propagation. Okay, number one. Number two, we know that each particle has certain amount of energy, and energy is not transferred from one particle to another. Okay, so this is the second point. Okay, now how standing wave is produced? In the past years, these are very important concept. Okay, now standing wave is produced by using the principle of superposition. What principle? Principle of superposition. Now if you refer here the principle of superposition, it says what? That the resultant displacement, okay, y at a point due to there are two wave, okay, equal the vector sum of the displacement y1 and y2 of the wave at that particular point. Okay, so what does it mean? Okay, now let's look here. We have now the first wave. Okay, the first wave. All right, so this is the incident wave. It goes here, and then he hits on a particular end, and then after that what will happen? This is the first wave, which is y1, and then what will happen? This wave that hits at the one end will be reflected. Okay, will be something like this, will be reflected, and this reflected wave is called as y2. So according to the principle of superposition, it says the resultant displacement y is equals to y1 plus y2, and it's a vector sum. Okay, it's a vector sum. So this is what principle of superposition says. All right. Now, if to produce a standing wave, okay, if you see y1 is a progressive wave, y2 also progressive wave. So when these two waves superpose, what will happen? It will form a standing wave. Now that is a condition. Okay, there is a condition. The condition is these two progressive wave of the same amplitude and frequency traveling in the opposite direction. They must be the same amplitude, they must be the same frequency, but they're traveling in the opposite direction. Like example, y equals to maybe a sine omega t plus kx, then this is y1, then the y2 must be a sine omega t minus kx. So that means same amplitude, opposite direction, and same frequency. Okay, now standing wave is derived by using the principle of what? Is derived by using the principle of superposition. Okay, as I was mentioning this now. A standing wave is produced by the superposition of two progressive waves of the same amplitude and the frequency and traveling in the opposite direction. This is the basic. You have to know what is a standing wave, you have to know how to form a standing wave, and you have to know a little bit of the characteristic of a standing wave. Standing wave is also called a stationary wave. Okay, now let's look at the equation of a standing wave. Okay, now we know that we have already learned, okay, that in our previous slide is produced by the superposition of two progressive waves of the same amplitude, frequency, traveling in opposite direction. Okay, so I have the first wave, the first progressive wave here, which is y1, same amplitude, okay, with this y2. Okay, these two are progressive wave. Okay, y1, y2 progressive wave, same amplitude, same frequency. Okay, frequency, how do I know same frequency? Because omega equals to 2 pi f, correct or not? Omega is equals to 2 pi f, and then we have opposite direction. One is positive, one is negative. Now this is plus, means it moves in the negative x direction. If it's negative here, means it moves in the positive x direction. So you refer back to your Johm revised progressive wave. Okay. Now these two waves, y1 and y2, will superpose. Based on what principle? Is based on the principle of superposition. Okay, so then therefore when we want to get the equation of standing wave, we need to use the principle of superposition, which is we have to take y equals to y1 plus y2. Who is y? Y is called as the resultant displacement. Okay, who is y? Y is called as what? Resultant displacement. Okay. All right. Now, what are we supposed to do first? Okay, so now we look here. This is y. Okay, this is y, the resultant displacement y. And then we take the first progressive wave. Okay, we plus with the second progressive wave. Okay, and then once when we plus this, how do we solve this? Now we'll refer to our prior knowledge in our maths, where sine A plus sine B, you get this. So you apply this whole entire concept. When you apply, okay, now who is A, who is B? All right, so here, if you see here, sine A, this is A, and then this is B. Okay. Now, hold on. This is what? This is A. This is B. Okay, then you take A plus B divided by 2. Then you take A minus B divided by 2 is your maths. So, you will get your final answer. After, not final answer, you will get, once you have resultant, you have add up these two, you will get this formula. 2a sine omega t cos 2 pi lambda x. Okay, now we want to improvise this equation. What do? We bring cos 2 pi lambda x to the front. Why? Because x is distance, and then we know as the distance increases, it will affect the amplitude. Okay, x will affect the amplitude. So therefore, if you realize here, you will notice that 2a cos 2 pi lambda x is actually what? Is actually amplitude. And amplitude varies with distance x. Okay, amplitude varies with distance x. Okay, so if I compare with a general equation, it's something like this, right? A sine omega t. Betul. So this one is A, this one is A sine omega t. So this is how, and this is what is standing wave equation. Okay, this is general standing wave equation. Okay, now let's look back to that question, having a little bit basic foundation of what is standing wave. Now let's look back in this question, which is back years STPM 2019. A string with one end attached to an oscillator of frequency 30 Hz and the other end to a mass of 200 gram. Okay, so the mass is 200 gram over a pulate to produce standing wave as shown in the diagram below. Okay. Now, describe the formation of standing wave in the string. Okay, now the keyword here, 2 marks. So, in our previous slide, we already know how is standing wave is formed. It is formed by the superposition of two progressive waves of the same amplitude and the frequency but traveling in the opposite direction. That is how it is formed. Okay, that is for number A. Okay, now let's look at B. Determine the wavelength of the wave, right? So we know by concept, yeah, we know by concept distance between knot. Okay, now standing wave, when it is formed, it will produce, let me see here, it will produce knot. Okay, at the end here is called knot, this is called knot, this is called anti-knot, anti-knot, and this is knot, and this is anti-knot. Okay, this one is knot. Okay, so it asks you to determine the wavelength of the wave. Now, distance between knot to knot, okay, knot to knot is half lambda. Okay, half lambda. Or distance between anti-knot to anti-knot is what? Is half lambda. So, lambda is what? Lambda is 2 times distance between anti-knot or distance between knot, which they already given here is 40 cm, which is the distance between two knot. Okay, so you take lambda 0.4 times with 2, you get 0.8. Okay, and you must convert your unit into a SI unit. Okay, so that is 2 marks here. So this is 1 mark, this is 1 mark. Okay, this 1 mark doesn't come because your substitution. This 1 mark comes because you know of this concept. Okay, all right, the next question is calculate the speed of the wave in the string. Now when we talk about the speed of the wave, we know V equals to F lambda, the famous formula. Okay, so now we know what is lambda. F is 30 Hertz. So we substitute and we get the value of V. So your 1 mark comes from here and another 1 mark comes from here. Substitution don't have marks. Okay. All right. The next one. Determine the mass per unit length. Mass per unit length of the string. Okay, so how do we do that? Now, when we talk about the mass per unit length of the string, we go back to the very important formula of V equals to square root of T over mu. T is actually tension and mu is mass per unit length. You have to memorize this formula because this formula is very repetitive in the past years. Okay, they're quite famous in the STPM. This is uh, the speed of the wave in the string. Okay, so we only use this when it is associated with string. We don't use it in anywhere else. Okay, so V is 24. T is tension. Now, tension, if you look at this part here, this is mg. Okay, there's a force, mg here. So, mg is equals to tension. Okay, so tension is 0.2. So, be careful. You have to convert your gram to SI unit. So, you get 0.2 times 9.81. And then you substitute inside this formula. And then you will get the answer for your mass per unit length. Mass per unit length is actually referred to which? Is actually referred to mu. Okay, and you get your answer. Okay, now let's look back on this question which came out in STPM 2016 objective question. Yeah. Okay, now it says here two similar progressive wave. We again have two progressive wave traveling in the opposite direction. Okay, with wavelength. Okay, so we know lambda is 1.0 of 1.0. frequency of 50 hertz, frequency is 50 hertz, sorry, 5 hertz, amplitude of 0.2, okay, 0.2. At time t equals to 0, the displacement at x is 0. Okay, now, what is so important with this keyword? At time t is equals to 0, the displacement at x is 0. Now, the keyword is very important. That means this sentence here means that it's a sine function equation. It's a what? It's a sine function equation. Okay, so let me look at this. Like, okay, like here, if I have, okay, if I have, this is amplitude, yeah, this is displacement, this is displacement, this is t. So at time t equals to 0, the displacement x is 0. The displacement at x is 0. That means what? That means it's a sine function graph. Okay, so you must remember that. What is the expression? What is the expression of a resultant wave when the two progressive waves superpose? We know when two progressive waves superpose, that means it will form a stationary wave or a standing wave. Okay, now let's check on the two similar progressive waves. Okay, all right. Now, this means it's a concept of principle of superposition. Okay, so go back to our basic here. Y1 is equals to 0.20, which is the amplitude sine, because according to this statement, it's a sine graph, a sine function equation. And then we have omega t plus 2 pi lambda x. So this is a general equation. So I specify by putting all my particulars inside here, then I will get this, correct? So I put all, okay? So here is omega t. Omega is what? 2 pi f, correct? Okay, hold on. Okay, here, omega, this part here is what? Is omega t. Omega is what? Is 2 pi ft. So f is what? F is 5. So we get 10 pi t. Because if you see here, f is what? F is 5 hertz. Same goes to this. Same goes to this. This 2 pi is 2 pi lambda x. Correct? Sorry, is 2 pi over lambda, correct? So 2 pi over lambda, and since lambda is 1 meter, so I get 2 pi. Okay, so I assume the first wave is in the is a plus. That means it's in the negative x direction. So definitely the second wave, because I know the concept of superposition, which is the formation of standing wave, the other wave must be in the opposite direction, it must be in the same amplitude, it must be in the same frequency. So I can form the second wave already, the equation of the second wave. Now what I do is, I must use the principle of superposition. Okay, the principle of superposition in order to find the resultant wave, which is what? Which is y equals to y1 plus y2. So now, correct. This is correct. Okay, so here y1 plus with y2. So once I plus this, now how do I go to the next one? I must use my maths concept, my prior knowledge. Sine A plus sine B equals to this. So if you look at this, alright, hold on. If you look at this, this is A, this is A, this is B. Okay, this is what? This is A, this is B. So when the book says sine A plus B, then you must take A, this one, plus this A, then this one plus, and then divided by 2. Okay, so that's your maths. So once when you solve this, okay, and remember your A must times with 2. 0.20 times with 0.20. So you get 0.40. Then you get this, and then you solve it, and then you get your equation as such. okay, or we call it expression as such. Now if you notice, I bring the 2 pi x to the front in this place here. Why? Because this whole thing is amplitude. Because amplitude, this is amplitude, amplitude varies with distance x. That's why I brought it. So if you see this past years, the answer for this will be C. Okay, it's an objective question. So the answer will be C. Okay. Okay. Now STPM 2018 essay question. A standing wave is formed by the superposition of the progressive wave in B. Okay, standing wave formed by the superposition of the progressive wave. So they have started the whole entire question with a concept. Okay, now this one in B, you refer back to STPM 2018 B, page 173 of your practice tropical book. Okay, so I just have quoted the equation, the progressive wave in B here. I've straight have quoted this. You have done this before under Johm revised progressive wave. Okay, now let's move on with the reflected wave from the ends where the string is tied. Assume there is no loss in energy. Now the question asks us to state the principle of superposition. So the state means just state it. That means just write down what does the principle of superposition means. Okay, so here it says the principle of superposition of waves states that the resultant displacement at a point due to two waves equal the vector sum of the displacement y1, y2 of the wave at that point. So this is the in words, this is in mathematical, which is y equals to y1 plus y2. This one I've taught you in the last slide. Okay, now deduce an equation, okay, for the standing wave formed. Okay, so now they want you to deduce the equation. So they already say it is formed by the principle of superposition. So we have to use this concept in order to get the equation for the standing wave. Okay, now we see the first one, which the from B, we get y1 equals to 0.02 sine 40 minus 5x, correct? Definitely, the second wave will have the same amplitude, same frequency, and but in the opposite direction. So there will be, here will be minus, here will be negative minus, here will be plus. Then based on the principle of superposition, y equals to y1 plus y2. So we take these two things, we add up, and then you remember your maths concept, and then after that you apply inside here. Okay, so this will be your, hold on, this will be your A. Okay, this will be your A, and this one will be your B. Okay, this one will be the, hold on, this one will be your B. So you plus A plus B divided by 2. So you take this plus this. Okay, you take this plus this, you divide it by 2. Then cos A minus B, you take this minus this part here, minus divided by 2. So if you know your maths, you know how to do this. Then when you solve it, you get your answer. Always remember, even though here it says 2, but it's actually here because it's 1. The amplitude is 1 here, so it's 1. So that's why they put 2. But if your amplitude is 0.02, then you'd take 2 times with 0.02. Okay, then you get your equation. So this is like 3 marks. So where do I give my 3 marks? Okay, first thing, I will give my 3 marks because one, I know the progressive uh, wave, the second progressive wave, number 1. Number 2, okay, number 2 is my maths for solving the principle of superposition, and number 3 is my final answer. Okay, all right, so that will form 3 marks here. Okay, now next one, Determine the amplitude of the standing wave at x equals to 0.45. Now, the question want to test you by looking at the equation, where is the amplitude? So here, if we realize that we have to rearrange the equation of the standing wave, okay, we put cos 5x and then sine 4t. Now, why do we do such? Because we know that the x will vary, the amplitude will vary with x. So this whole thing is an amplitude. That's what they want to test you. Okay, so that's why you see here, I took the amplitude because this whole thing is amplitude. So 0.04 cos 5x, then I substitute x with 0.45, masuk dalam sini. Then 5 times 0.45 is 2.25. Now when you get this, you cannot straight go and use the function of cos. This is in radian. You have to convert it to degree. Okay, so you see how I convert it. Once I've already converted, I solve this, then only I can use the function cos. Then I times with this, then I get my answer 0.025. So be careful with this. Okay, this is something you should know. All right, now the next question. They ask you to determine the minimum length of the string used. So it's a string. We know minimum length of the string used. Now the basic concept here, minimum length of the string used, we know it is a fundamental mode. Okay, because fundamental mode, so we know L equals to half lambda. Alright, so this one you will see under Geom Revise for sources of sound. Okay, sources of sound. Okay, which I will be giving you later. All right, so here L equals to half lambda, and then what do? I want to know what is okay, now let's look at this. Okay, hold on. Okay, now here is the equation that I got. Okay, correct. Then I compare with a general stationary wave or standing wave equation. So I realize that 2 pi lambda is actually 5, correct? So 2 pi lambda is equals to 5. Now why must I do that? Because I want to know what is lambda. I want to find the value of lambda, betul? So I solve this, I get my lambda is 1.26. Now from this fundamental mode concept, so L is equals to half lambda, and then lambda is 1.26. So lambda is 1.26. So what is L? Okay, wait. 1.26. So what is L? L is 0.63. Okay. All right.